China is fighting to keep pace with America's low Earth orbit satellite leadership. In a daring move in 2026, China submitted petitions to the International Telecoms Union requesting permission for over 200,000 satellites in low Earth orbit. The application asking for permission for 12 different satellite constellations in addition to 3 already being developed. The Chinese company, ADA Space Technology, has unveiled a plan for a massive 2,800 satellite space-based data center called Starcompute. This space-based AI computing infrastructure aims to build a processing web to serve autonomous vehicles, drones, and robots. China was a late entrant to geostationary satellite internet, but it's now aggressively deploying some of the world's most ambitious low Earth orbit broadband constellations, becoming the biggest challenger to the dominance of the US in the broadband satellite space. The very first commercial services was provided by American satellites designed for television and telephony. Telstar 1 launched in 1962. However, these were not internet satellites. The 1990s saw the first concrete versions for low Earth orbit internet from space. The most famous was Teledesic, an ambitious but ultimately failed project backed by investors like Bill Gates of Microsoft, which planned a massive constellation of low Earth orbit satellites. But the title for the first successful satellite dedicated to consumer broadband internet goes to Eutelsat's eBird, launched in 2003. This was a French geostationary orbit satellite that mainly served internet to remote areas, islands, and rural areas. Geostationary satellites orbiting at about 36,000 kilometers became the global backbone for television broadcasting, telephony, and early internet because a single satellite could cover a third of the planet. American companies HughesNet and Viasat later came to dominate this premium-priced geo-internet market for decades. However, the high cost of geo-internet and the poor download speeds made the services uncompetitive in every scenario except in remotely located oil rigs and mines. The great distances of geosatellites caused high latency, making real-time applications difficult, further limiting the technology's appeal. In 2015, American billionaire Elon Musk announced he was developing Starlink, a low Earth orbit broadband constellation. By operating at altitudes of between 500 to 2,000 kilometers, LEO networks offer dramatically lower latency and higher potential bandwidth. But their closer distance to the Earth's surface means you need hundreds of satellites to cover the Earth. In 2019, Starlink launched their first batch of 60 satellites. The Hongyu 3 constellation represents the third and currently furthest behind Chinese player. The project is led by the Blue Arrow Hongqing Technology Company, the parent company of the private rocket firm Land Space. It is the newest entrance among China's mega constellations, having filed its plan for 10,000 satellites with the International Telecoms Union in mid-2024. Blue Arrow Hongqing Technology Limited was established in November 2017 in the Beijing Economic and Technological Development Zone. The company focuses on R&D and intelligent manufacturing of low-orbit broadband satellites and plans to construct a giant constellation. As of late 2025, Hongyu 3 is still in the planning and filing stage, with no satellites yet launched. Its primary distinction is its corporate structure. Its close connection to land space is reminiscent of the vertically integrated model used by SpaceX with Starlink and Blue Origin with Kuiper, potentially allowing for streamlined launch services in the future. However, given its late start and the immense resources already dedicated to Guowang and Qianfan, Hongyu 3 faces a steep climb and its future role in China's satellite internet strategy remains uncertain. Hongyu 3's single-cell strategy of 10,000 satellites at about 600 km orbit will provide low-latency internet to everyone, especially the remote regions. The constellation's rigidity leaves polar regions underserved, sacrificing global reach for administrative simplicity. This uniform altitude balances coverage across 160 orbital planes, optimizing mid-latitude service for China's Belt and Road partners. The satellite, like most other LEO satellites, will be compatible with 5G NTN mobile services and can be upgraded to provide direct-to-device services. 5G NTN is a mobile technology where mobile operators use satellite communications to link their service to local base stations instead of using fiber optic cables. This technology is normally applied for mobile coverage in remote villages where connection via laying fiber optic cables is prohibitively expensive. Globally, the Chinese aim to serve Belt and Road Initiative partners in Asia, Africa, and Latin America, positioning themselves as alternatives to Western systems. The integration with China's digital Silk Road could enhance diplomatic influence as geopolitical tensions loom. By targeting niche markets, Hongyu avoids direct clashes with broadband giants like Starlink while leveraging China's manufacturing scale and BRI partnerships to sell its services. Internationally, concerns persist over data security and China's potential influence over critical infrastructure in partner countries, but that's a concern about every provider. But with Huawei controlling 70% of Africa's 4G infrastructure, the Chinese require minimal introduction. Nigeria signed a $550 million deal in 2024 integrating Guowang with 5,000 Huawei base stations. North America and Europe will be inaccessible due to US-led sanctions and distrust of Chinese data governance. The US and allies have raised concerns over data sovereignty and security, while regulatory hurdles in markets like Europe and India may complicate expansion. India, with 700 million unconnected users, will block Chinese infrastructure over security concerns, favoring partnerships with OneWeb, Starlink, or even Russian Bureau 1440 instead. Vietnam and Indonesia increasingly view China's tech through a security lens, will prefer their own sovereign solutions or hedge between the Chinese, Americans, or even the Russians. For China, pursuing this despite the staggering cost is a calculated strategic decision with a business model focused not on Western consumer markets but on serving their military, their vast domestic market, and aligned nations in the global south. With a massive protected home market with over 1 billion internet users and geographic challenges in rural western regions, domestic demand is substantial. The government can mandate or incentivize the use of its sovereign constellations by state enterprises, telecoms, and for critical infrastructure, ensuring a baseline of usage. Guowang's development is inextricably linked to China's national security services, providing funding, stability, and access. Unlike commercial ventures, Guowang benefits from guaranteed defense funding, ensuring deployment continuity despite market fluctuations. This model ensures that even with high costs, the constellations serve vital state objectives: military sovereignty, domestic control, and global influence. Their commercial success with international partners is secondary to these strategic aims, allowing the project to proceed even with the challenging economics. The Qianfan and Hongyu, on the other hand, will have a harder time justifying their existence if they don't gain success outside China. Hongyu 3 enters an already crowded domestic arena with two Chinese mega constellations, the Guowang and Qianfan. Together, they are vying for China's 300 million unconnected users and the countries in the global south. This tripartite competition creates critical challenges. With 38,000 planned satellites between them, these constellations risk saturating China's addressable market before achieving economies of scale. Qianfan, supported by Shanghai municipal government, has secured early international contracts with Brazil and Thailand. Hongyu 3, though, lacks equivalent political capital, potentially relegating it to the weakest and most likely to fail of the three. And that's not all that will be coming from China. In early 2026, the Chinese submitted papers to the International Telecoms Union requesting space for over 200,000 satellites. The application asks for permission for more than 12 different satellite groups. Some of these will be constellations for mobile operators, for direct-to-device constellations, and others will be for AI data centers in orbit. But building and launching hundreds of thousands of satellites will require years of building supply chains and enormous financial resources. We will revisit to see how this competition pans out.